Heart disease is the #1 cause of deaths in the United States, accounting for 1 in every 4 deaths. While strides of progress has been made towards preventing heart disease and sustaining life after a heart failure event, a lot of what happens in a diseased heart is still not fully understood. Now, when you all think about a healthy or a diseased heart, a healthy heart, let's say, the first thing that probably comes to your mind is a rhythmic pulsing ECG that we're all familiar with. And when the heart is failing, you probably can see these disturbances in your ECG. But these are recorded from outside your body. What's actually happening in your body is that your muscle cells that contract are actually sending signals, transfer electrical signals in a smooth pathway as shown here. These get interfered and they go around in a very unorderly fashion. What's also been observed that your heart undergoes structural remodeling, where you see an increased amount of your fibrous cells shown in red here. So one of the reasons it is believed that a significant, the electrical signal, the disturbance in the electrical signals that you see is majorly due to the interactions between your muscle cells and your fibrous cells. And the more severe the condition, the more the interaction between these two cells. So this is very hard to reproduce in an actual live animal for scientists to study. And what I have come up with in my research is a simpler way of doing these studies, and I call it the heart tissue on a chip. So what we do here is, not only am I able to mimic a healthy and a diseased state, but I'm also able to mimic heart tissues that mimic intermediate and different levels of the disease state in my heart tissue on a chip. So what I have done is, using the fabrication technique for making electronic chips, I've implemented to fabricate my chip. So what I do in my chip is we have a thin microporous membrane where we plate heart musculature cells and fibrous cells isolated from rats on either sides of this thin microporous membrane. The micropores in this microporous membrane actually control the interaction between these two cell types. So the more severe the heart condition, the more pores you have, because it will allow more interactions. So using that, and the way we know that the measure of the healthiness of the tissue is, in a sense, the electrical signals in your heart that you record from the heart tissue. We have very tiny microelectrodes in this, embedded in the microporous membrane that can record the healthiness of the tissue. So if you're a scientist who's trying to discover a drug that helps improve this conduction in the heart tissue, instead of putting your resources towards doing experiments with animals, you would want to go and do experiments with my heart tissue on a chip. Thank you.